Have you ever experienced a computer program that runs perfectly fine without crashing, yet produces results that just do not add up? It processes data, completes its tasks, and seems to function, but the final output is clearly incorrect or unexpected. This can be one of the most frustrating challenges in programming. Logical errors fundamentally cause a program to behave incorrectly or produce an unexpected output, even though the code itself executes without any syntax errors or runtime exceptions. Unlike syntax errors, which prevent a program from running, logical errors allow the program to run to completion, but with a flawed outcome that deviates from its intended purpose. The core reason behind logical errors lies in flawed algorithm design, incorrect assumptions made during development, or mistakes in translating a problem's solution into executable code. The computer faithfully follows the instructions you provide, but if those instructions are themselves logically unsound, the program will produce unsound results. This could manifest as incorrect mathematical formulas, improper conditions in decision structures, such as an if statement, subtle off-by-one errors in loops, or simply mishandling data in a way that leads to an illogical outcome. These types of errors are particularly insidious because the program does not explicitly tell you it has a problem. It just gives you the wrong answer. To effectively identify and correct these elusive errors, developers employ several key strategies. Rigorous testing is paramount, involving the creation of specific test cases with known inputs and predictable, correct outputs. When a test case fails, it signals a logical discrepancy. Utilizing integrated debugging tools allows programmers to step through code line by line, inspect the values of variables at each stage, and meticulously observe the program's flow. Simple print statements or logging can also be invaluable, providing a temporary window into the program's internal state and helping trace execution paths. Furthermore, collaborative code reviews, where other developers examine the logic, often uncover flaws that the original programmer might have overlooked. Understanding concepts like idempotence and the use of preconditions and postconditions can significantly aid in preventing and detecting logical errors. An idempotent operation is one that can be applied multiple times without changing the result beyond the initial application, ensuring predictable state changes. Preconditions define what must be true before a function is called, while postconditions describe what must be true after it executes. By formally defining these, you establish clear logical boundaries for your code, making it easier to spot when an operation or function has not met its expected contract, thereby indicating a logical error. Ultimately, logical errors are silent saboteurs of software reliability, transforming perfectly executable code into an unreliable tool that generates incorrect information. Preventing and finding these errors demands a systematic and disciplined approach to program design, thorough testing, and meticulous verification. This commitment ensures that your programs not only run but also consistently deliver accurate and intended results, building trust in their functionality.